Hello again. In this video, we'll introduce you to numeric modeling and how to create your first grade estimate. At the end, we'll also combine the models that we built in part 1 of these videos and evaluate our numeric models on the geological models that we've created there. But first, let's have a look at our assay data here. So we have a bunch of drill holes that we've imported in the first video. On the left hand side, you can see the assays here. So they're colored by copper. We can switch that to show the gold. And like we've done for building lithological models and other categorical models, we can actually start by creating our implicit functions directly from our drill data. When you bring this up, you can switch between assays and geology here because these are the drill sets that we have. And we'll start by modeling the gold. So we can switch any of the attributes. Like with the categorical data modeling, we also want to create a model at the end. I'll show you what the difference is with just the interpolation and the model itself a little bit along the way. The first step is to set up our interpolation type. So here we have different ways of interpolating. So we can use radial basis functions, ordinary kriging, or inverse distance weight interpolation. But the default is to use ML regression. The estimated mean is automatically estimated from the drill data. We don't really need to set it here unless you have an idea of what the range that you want to use, but we haven't really covered that yet. So we'll just leave the default for now and we'll hit OK. Then we specify in the next stage what we want to model as an output. For the gold, we can specify either a grade shell, a tetrahedral model, or traditional block model. Finally, we can set our cutoff grade. We'll set it to 1 gram per ton here and we'll hit OK. In the meantime, you can see that, yes, we override that one. There already is an implicit function, but it just didn't show up. I'll turn off the grade shell for now. If I click on the implicit function here and we can go to our color, we can actually set a cutoff grade. So we can actually dynamically vary the cutoff grade to our particular cutoff of interest. We set it at 1 gram per ton. So if I turn it off, it's actually used this implicit function, which we can preview here, and actually created a triangulated surface as an output here. You can see that it's closed at the bottom and it's one consistent volume. If you go to Info tab, you can see that it's shown as a surface that's closed, and you can get a volume estimate at 1 gram per ton this way. Likewise, we can also run the same for our copper. So here we've interpolated a copper grade at 1 gram per ton. But if we look a little bit more closely at the actual assay data for the copper, and we start to look from the side a little bit, we can see that the copper is actually more or less banded. You can see a top band here, then you can see some very thin bands there, and then the last large area at the bottom here. In our default interpolation, this is what was produced, but you don't really see those bands. It's a lot more rounded. And that's because by default, the interpolations will assume isotropic interpolation. In this case, for the copper, that's actually not really the way we want to model it because we don't see the band. So we run the one for the copper, but in this case, we don't want to create a model. We already have that here. So again, use ML regression, leave distance as it is. So we created the distance buffer and we have copper interpolation. So here we can go to 1 gram per ton in the preview. But this time we want to bring up the workflow for this one. Every item that you're creating, which is part of your modeling process, if you created it within GEOREKA from version 5.2, if you right click on this one, you can show the workflow that was used to create this object. So in this case, we select the workflow for the copper interpolation, and it shows you this workflow here. It takes the assay data, that's this object here, representing the data in our project tree, and it's connected that to interpolation here. And in this case, it's actually using the interval midpoints, and these interval midpoints are then interpolated. If you go and double click on our interpolation function here, you get a number of parameters. One of the most important ones that I want to focus on here is this estimate anisotropy. Like I said, the copper interpolation is a very banded, but in our interpolation that didn't really show up. And that's because we use an isotropic interpolation. Again, we'll use the estimated anisotropy, but in this case, we actually estimate it by a planar anisotropy. We'll leave everything as it was, hit OK. So now we've changed our parameter for this workflow, and we can hit the run button at the top. Here there's a display or start processing button. We run this workflow, it's running the simulation, and when it's done, we can go back to our 3D view to see the result. And as you can see, the green is now a lot more continuous at the band here. You start to see more this banded items up here, and you can see that in general, the shape has changed to be a lot more planar. Now what we're going to do is actually turn this off, and we'll actually have a look at the workflow for creating a grade shell. So this seems a little bit more complex than it actually is. The start of this is very similar to what we've been doing for geological modeling, and I haven't shown the workflow for those yet, but it actually starts off with an empty model. So your empty model is the extent that you've defined, so your active region of interest, as it were, and it fills it up with an unknown, with a grid with everything labeled unknown. And then you start defining domains within this empty model. In this case, we had a distance buffer that was automatically created and that was applied to it. Here we see, similar to the geological model, we actually have a polarity and a threshold. So you see that the same distance buffer has been applied here. And we could set that to 150 as well, and then hit OK. But after that, what happens is that this function is then the function that we've created, this implicit function, the machine learning on the copper, is actually used to evaluate data on this grid. So if we double click on this one, you see all your implicit functions that have been created, and you see that the copper is actually being used for the evaluation in this case. And then what happens after that is that a shell is actually created from this evaluation, and we do an optimization step afterwards. Well, let me just remove this one. So I'll click on the optimization, and I'll click on the extraction of the shell, and I'll actually name this one eval CU, just to show you what actually happens in the background. If we run this one, take the implicit function, evaluate it on the grid, and I'll just turn this one off. Now you see that we have a model being clipped at 150 meters, but the evaluation is actually showing the domain here, which is not of interest. So we actually want to switch to our copper model, or copper evaluation, I should say. And here you see the evaluation on the full model grid. If we then go to our color settings, we can actually apply a range setting and say, okay, well, here we're roughly looking at everything above 1 gram per ton. You start to see the same shape that we've seen for a grade shell. Probably have to, increase this a little bit more just to see what it starts to look like. No, the grade shell wasn't created with that setting, so you could only look at the implicit function at the same setting, and you see how they match. But what's interesting about doing it this way, if you actually have a grid like this, is that you can actually switch over to the info tab. To the info tab, and you actually get an estimated average grade and the volume at this range level. If we go back here, we change our setting and say, oh, everything above, let's make it a bit more accurate, 0.5 gram per ton, and maybe clip that everything to 1. So you see there's a bit of a hole in there. We can actually go back to this and actually see what our average grade is and what the volume is. If we set this to the maximum, we can update it again, and you see how it updates the estimated mean value. We can do this on any sort of model, as it were. So if we go back to our workflow, here we started with an empty model, and we defined a domain and then evaluate it on that domain. And from there, we could actually extract the grade shell and do things that way. But we could also change the way we do things and actually remove this here move everything, so we just leave the evaluation there. In this case, actually drag in the geological model that we created before. But now we will evaluate on our geological model. Make sure that we have our copper evaluation on this and run this one again. This is quite fast because we had a lower resolution. Here we can have our domains. See, we can still have different subdomains, but also we have a copper grade. Now we have a combination of our copper evaluations on our model and the domains associated with it. The only thing you can't do is look at the evaluation just for the quartz porphyry this way. We would need to change things around a little bit. The easiest way to start doing this is by building a new model. So we have our implicit functions, existing models, and at the top here, we create a new model. We call this QZP only and hit OK. This dialog should look somewhat familiar. It's come up a few times when we've automated the workflows for building models. In this case, there are no domains added yet. That's what we need to do manually here. We start by clicking the Add button, find the function that we want to include. Normally, we'd still start with the topography, but in this case, we don't really need to because we actually are going to use the oxidation layer, which is below the topography, and we're going to remove this from the model. I'll hit OK here. So this will model everything above the oxide layer or the oxide boundary, and it means that we need to add the QZP as the second youngest unit there. So we add in this one here and we add the quartz porphyry. We want to remove everything outside of the quartz porphyry. But if we uncheck this one, we're actually going to be removing the quartz porphyry itself, and that's not what we want. So we'll still check this one, but here we switch our polarity. Now we're actually modeling everything outside of the quartz porphyry. So this should not be quartz porphyry anymore, but this should actually be outside of the quartz porphyry. And the outside of this inverted function that we're using will actually be the quartz porphyry. So everything that's going to be left behind. We've inverted the way we do the modeling here because we want to just keep the quartz porphyry. All right, so let's build this model. Just toggle this one off. Okay, let's turn everything off. So here we should have our quartz porphyry. Yes, there it is. And as you can see, this has been clipped by our oxide and it just sits beneath it. Just this quartz porphyry model, we can start evaluating just the quartz porphyry with our copper. For this, we go to our workflows tab. We take the model that we've just created, the quartz porphyry only. We click on it in the project tree and click on the canvas here. Then on the volumetric modeling, we can scroll down and you see that there's two gray areas here and there's evaluate data with existing function. Should all be reasonably familiar, but here we actually set up workflow ourselves. Connecting objects, you click the button here for connecting two points basically, and click on the quartz porphyry, then click on evaluate data, and it draws this line between them. If we double click on evaluate data here, we can set a parameter. We can give it an output name. We call this QZPCU. And now we select our copper interpolation function. Click OK, and we run it. And we can back to our 3D view. Let's turn this one on. Now we have our quartz porphyry copper selected on domains, but if we now switch to copper CU, we still have our quartz porphyry evaluated with our copper. Now on this one, we can start playing with thresholds if we want to, some cutoff ranges, and on the info tab, we can then see our relative volumes and the estimated mean. We'll just do a short recap of what we've been doing. We started off just looking at our drill data. We've chosen to automatically create models using the shortcut buttons at the top. This could produce triangulated grade shells for us for different attributes. And we then started to look into the interpolation that was done and how to adjust the workflow and set up the anisotropy for each interpolation that way. Finally, we use these interpolations to do evaluations on our models. So here we evaluated just on the quartz porphyry by creating a new model from the top here, only including the quartz porphyry and the oxidation layer. This concludes the quick starting guides for modeling with GEOREKA. We've shown you how the basics work for building geological models, both categorical data, numeric data, and how you can combine them. In the next set of videos, we'll dive into more details on the various topics. Hope you've enjoyed it, and see you in the next video.